Have you ever tried to understand a new crypto concept and just felt completely lost in the jargon? Yeah, we've all been there. Today, we're going to tackle something called quantum proof of work, or qPoW. But don't worry, we are throwing out all the complicated stuff. Instead, we're just going to use one simple analogy that'll make it all click. All right, let's get into it.
So let's just start with a basic question. When you think about crypto mining, what comes to mind? Chances are you picture these huge warehouses packed with computers just guessing numbers as fast as they possibly can. Just pure, raw, brute force. But what if that's not the whole story? What if there's a totally different way to play the game?
And that brings us to the core idea of this entire explainer. We're going to look at two completely different kinds of competition. On one side, you have the game of rolling dice fast. And on the other, you've got the game of solving puzzles smart. And I'm telling you, this simple comparison, it's the key to understanding everything. Okay, so let's start with the one we're probably all familiar with, the game of speed. This is your classic proof of work, the engine that runs networks like Bitcoin. The rules here are super simple. Every single miner out there is basically rolling a giant digital dice over and over and over again. If your roll happens to come up with a number that's low enough, you win. And that's pretty much it. The whole game is just pure raw luck times how many times you can roll that dice every single second. So this leads us to a word you've probably heard a million times, hashrate. In our little analogy, hashrate is just a fancy way of saying how fast you can roll the dice. You got more computing power? Well, you can roll the dice more times per second. It's really that straightforward. And what about difficulty? Well, the network can actually make it harder or easier to win. In our dice game, that just means changing how small the winning number needs to be. So if the difficulty goes up, you're not just looking for a number under, say, 100 anymore. Now, maybe you need to roll a number that's under 10. And here's the most important part to get. In classic proof of work, every single miner is rolling the exact same identical dice. There's no special technique, there's no clever little strategy you can use. The only advantage you can possibly have is just being faster than everybody else. Okay, so we get the game of speed. Now let's completely flip the script and look at a new kind of game. This is where we introduce quantum proof of work, or qPoW. So forget all about rolling dice. In qPoW, the game changes completely. Instead of just a mindless, repetitive task, miners are given a small, unique puzzle to solve with every single attempt they make. And finding a good enough solution to that puzzle is how you win the block. Now, what do I mean when I say mini puzzles? Well, think of things like arranging a set of tiles into a very specific order, or maybe estimating a really complex pattern, or even completing a partial jigsaw puzzle. It's all about finding an approximate solution to a tricky little problem. It's a game of skill, you see, not just pure speed. And here it is. This is the single biggest change. In qPoW, every miner can choose their own way to solve the puzzle. Some might use a really fast, kind of sloppy method. Others might use a much slower, but way more clever one. And this is where strategy finally enters the picture. So this whole idea of different strategies, well, it leads to different types of players, or what we can call solvers. So let's look at three totally distinct ways you could play this new puzzle game. Okay, just look at this table. It really lays it all out. You could be miner A, right? This is the smart, complicated strategist. Your attempts are a bit slower, but the solutions you come up with are really high quality. Or you could be miner B, who just tries to brute force it. Tons of attempts, but most of them are pretty low quality. And then you have miner C, who uses some kind of intelligent guessing algorithm. Way fewer attempts, but the accuracy is incredibly high. You see? 3 miners, 3 completely different ways to win. So let's just pull back for a second and really lock in why this analogy of dice versus puzzles works so well for understanding what's going on here. This slide really brings it all home. Let's compare the key terms. In the PoW dice game, hashrate is all about roll speed. But in the qPoW puzzle game, it's about how many solutions you can submit, and not all of them are created equal. Difficulty? It's not about how small the number is anymore, it's about how good your puzzle solution has to be. And luck? Well, it's no longer just pure random chance. It's randomness plus the quality of your personal strategy. So here are the 3 big things to take away from all this. First, qPoW is not pure brute force. The quality of each puzzle you solve is what really counts. Second, different miners can have wildly different puzzle-solving strategies. And third, Yeah, luck is still a factor, but a smarter algorithm can actually make you luckier more often. Look, if you remember just one thing from this whole explainer, let it be this sentence right here. Classic Bitcoin mining is like rolling dice as fast as you can. qPoW mining is like solving tons of small puzzles, where having a better strategy directly means you win more often. And this leaves us with a really fascinating final thought. If mining isn't just a race for raw speed anymore, but it's a competition of strategy and cleverness, what kinds of new, creative, completely unexpected puzzle-solving strategies are going to pop up and win in the future? Now that's a space worth watching. Thanks for tuning in.